Okay, we're going to look at how to make the sine graph and cosine graph using radian units instead of degrees. And we're going to try and create this from what's called the unit circle. Okay, so I've already got this pre-drawn for you for the sine graph. So this is the sine, is going to be the sine graph. We're going to transfer these rotational units, okay, these angles, to a linear axis here. And we're going to see what effects that has on sine of theta. Okay, so this is the theta axis, which has been this rotational part here going from the positive x-axis here. Okay, that was x and y, and we're going to rotate around from the positive x-axis counterclockwise. And I've already marked in these angles here. So these are from our special triangles, the 1, 1, root 2 triangle, and the 1, 2, root 3 triangle, which we've seen in a previous video. Okay, so in this angle here, this is the angle of pi over 6. Okay, so pi over 6, and the next one is pi over 4, and the next one will be pi over 4, and the next one will be pi over 3. Okay, so formerly 30, 45, 60. And then so on, multiples of those. Okay, and then up here is going to be pi over 2. Over here is pi. So it's 3 pi over 2. And we can mark the angles around here. So this is pi over 6, 2 pi over 6, 3 pi over 6, so 4 pi over 6, which is 2 pi over 3. You can count it out like that. And then this is 5 pi over 6. Okay. This is pi over 4, 2 pi over 4, so 3 pi over 4. And so on. You go around the circle like this. Now, we're going to call the radius of this circle equal to 1. Okay, so that's going to be 1, negative 1, negative 1 down there, and then 1 over here. Okay, so the radius of the circle is 1. And to create this, I just drew a circle in so I get it across the page. The convenient size was a diameter of 7 centimeters. And then this axis here, we need to have about 12 centimeters here to get in 2 pi radians across here. Okay, so I divided this up already. So if 12 is 2 pi, 6 is going to be pi, 3 is going to be pi over 2, and then 1.5 is going to be pi over 4. And if 6 is pi, then pi over 6 is just at 1 centimeter. So it makes it convenient. So 12 is a nice measurement to have for 2 pi so that we can divide it up into nice numbers here. Okay, so I write 2 pi here, and then this would be pi. This is pi over 2. So 3 pi over 2. Okay, and then the quarter pi, so pi over 4. 3 pi over 4. 5 pi over 4. And 7 pi over 4. And then up here, these are the multiples of 30 degrees, or pi over 6 radians. So there's pi over 6, pi over 3, okay, then 2 pi over 3, okay, and 5 pi over 6, and so on. You can go across and finish that. And the way we do this, well, sine theta, so if y equals sine theta, we get y over r for that from these, right? So y is this coordinate, x is this coordinate here. Okay, so it's a different y than this. Ends up being the same in the end. Now, with r equal to 1, makes it really convenient if we use this unit circle with r equal to 1, because y over 1 is just y. Okay? And it's this coordinate here. It's this vertical height. So sine of pi over 6 is y over r. Okay, so y, there's the height over r. So sine of pi over 6 is going to be this height over 1, which is just this height. So at pi over 6, I just go across here and put that dot. Okay? Now sine of 0 is y over r. R is 1, but y here at this point is 0. So sine of 0 is 0. Okay? So I go across like that. Okay. And mark it like this. And then at pi over 4, well, I go across again at pi over 4. And I get a point up here, right above pi over 4. So that's my second point. And then at pi over 3, well, this is the angle here, pi over 3. Okay, so I go across from there. Okay, and I go up. And I get that point. So there's 3 points on the sine graph already. And then at pi over 2, sine of pi over 2 is y over r. So y is equal to 1. R equals 1. So 1 over 1 is just 1. So again, it just goes straight across here. Okay. Right above at pi over 2. Okay. And there's that point. So to get the next points, we do the same thing. We just go up to 2 pi over 3. And the same thing, the y value is going to be the same as it is for pi over 3. So I just map it straight across to above 2 pi over 3 here. And then I go up from 2 pi over 3 to make that dot. And there I go, I've got that dot. And the same thing over here with 3 pi over 4. Just going straight across. Okay, get that dot. And then 5 pi over 6. I go straight across. And I get that dot. And then at pi, it's the same as it is at 0. At pi, the y is 0, so I get 0 at this point here. And then you can just join them together. Nice curve. And you do the same thing down below, and you'll get the bottom half of this graph here. This is the sine graph. Okay, so at 3 pi over 2, it's down here, and so on. And so you get a nice curve. Okay, like that. And that's the sine graph between 0 and 2 pi. Now if you want to do the cosine graph, do the same thing, but cosine equals x over r. Okay, same thing. This is going to be a radius of 1. So 1, negative 1, 1, negative 1, like that. And so r equals 1. So this is just going to equal x. Except in this case, I'm going to make the x-axis here for my unit circle, and the y-axis there. So that's going to be 1 and 1. This is going to be negative 1. And this is going to be 0 radians, and I'm going to rotate that way. Okay, same as I did before, but now I've kind of turned that by 90 degrees, or pi over 2 radians. Okay, so I've got that. So now instead of pi over 4 being here, this is pi over 4. Okay, and this is pi over 2, and then this is pi down here. This is 3 pi over 2, and this is also going to be 2 pi. Okay, so starting from here, rotating that way, and so that now when you've got cos of theta equals x over r, we're just going to map the x coordinate straight across. Okay, so cos of theta is going to start at 1 because x is 1 at 0 radians. Okay, same thing on this axis, 2 pi, there's pi, pi over 2, pi over 4, pi over 6, pi over 3, and so on, and you can fill those all in. So this is going to be at 1, so mapping that straight across. Again, we get 1. Okay, and then at this angle over here, so pi over 6, I go there, pi over 4, there, and pi over 3 is at a half. Okay. So we go up. There's a point. There's a point. There's a point. And then at pi over 2, the x coordinate is 0 here. So I got that. You join them together, and you get a nice curve here. Now when you go down below, it's going to be the numbers down below. Now notice on the axis here, I put the 1 over root 2, 1 half, 1 over root 2, and root 3 over 2. Those are the ratios from the special triangles when you do sine and cos of pi over 3, pi over 2, pi over 6. Okay, so these are all put in there for you. You can measure those out. You've worked them out as a decimal. If this is 3.5 high, then you can just work that out yourself to see where they're supposed to be placed. But they should be right where these, right across from where these are. Okay, so for this one, then at pi, you're going to be at -1, and you're going to head down like this. Should look something like that. And then at 3 pi over 2, it's going to be back up at 0. At pi, it should be back up at 1. And you should end up with a graph that looks like that. Okay, so that would be the cosine graph between 0 and 2 pi. And you could fill in these empty spots here with the proper fractions as you've seen in the previous videos. Okay, so that's for sine and cosine.